that the astronauts read out.
Gravitational effect of those planets.
Hey, I'm Kristen, and this is NASA Now. As NASA continues to push the boundaries of space exploration, the importance of robotics for both manned and unmanned missions continues to expand. Today, we'll be talking with an expert who will share his insights into the new generation of human robotic exploration. That's ahead. First, here's what's happening at NASA Now. NASA's Research and Technology Studies, better known as RATS, conducted a test of the multi-mission space exploration vehicle at Johnson Space Center in Houston, Texas. The tests were designed to determine the functionality and habitability of the MMSEV. The flexible architecture allows the vehicle to rove on a planetary surface or fly in space using advanced in-space propulsion systems. To simulate the vehicle traveling across an asteroid, the MMSEV was placed on a sled on a special air-bearing floor which allowed the craft to hover. The lab was configured to create an immersive environment incorporating state-of-the-art virtual reality in which the EVA crew members trained. Based on lessons learned during the Apollo missions, which allowed astronauts to traverse the surface of the moon, a new type of space exploration vehicle, or SEV, is paving the way for future space exploration. Today we are joined by Fernando Zumbado, a robotics system engineer at NASA's Johnson Space Center in Houston, Texas.
At JSC, I am part of the multi-mission space exploration vehicle team. Part of my job is to make sure that we design mechanisms that can function well with software and electronics. It's a very integrated discipline, robotics. So we have to make sure that all the pieces are working together in a very nice way, and it's something that's very challenging. For the past few decades, NASA has been exploring low Earth orbit with the Space Shuttle and the International Space Station, and we actually got very good at it. NASA is now trying to push the boundary. We're trying to explore beyond low Earth orbit. And in order to do that, there are several bodies we can visit. We can visit the moon, we can visit an asteroid, we can visit Mars. The MMSEV provides a modular capability where you can have a planetary mobility platform where you can move around on Mars, you can move around on the moon, but you can also have what is known as a RCS, which is basically thrusters that can help the vehicle maneuver in low gravity or in microgravity around an asteroid or another body of interest. So you can actually, from one vehicle architecture, you can actually explore several different locations and different missions. And that will help NASA push that technology boundary and explore a lot more of the solar system. The MMSEV in the planetary configuration is very different from either the lunar rover they used on Apollo or the Mars exploration rovers that are currently on the Martian surface. And the reason I say that is the Apollo LRV was an unpressurized vehicle, so the astronauts had to wear their spacesuits and they would sit on the vehicle. The MMSEV actually has a pressurized cabin where they could sleep, they could eat in there, and then they could rest after an EVA inside and move from point to point within that pressurized volume. When they need to do an EVA, they can step into their spacesuits through the suit port and then do their EVA. And then the Mars exploration rovers, they're very small, they move very slowly in the order of a few meters for a day. And that's something that you and I can walk in a few seconds. So the MMSEV kind of falls a little bit beyond both of those two vehicles. The MMSEV is a robot. Part of the things that we incorporate into the MMSEV permit it to be operated autonomously with some sensors that we can put on the front, on the sides. It also takes in some inputs from sensors inside the cabin. For example, you can control the temperature of the spacecraft inside. And you can also do something that is called teleoperation, where you would have a human controlling the MMSEV, but at a long distance, sort of like a very long distance remote control car. Make sure that you explore things in science. Not only do you want to understand physics, because it's a very important part of engineering, but for example, look at chemistry. Maybe you can integrate some of that into robotics. Make sure you look at biology. You can get a lot of inspiration from biology, a lot of what we call bio-inspired designs, because nature has been doing this for many, many years, and robotics is a fairly new field compared to nature. So we can take some of those ideas and extrapolate them into robotics.
Now that you know more about the crucial role robots have in our quest for knowledge about the universe, you can explore the rover in 3 dimensions to better understand NASA's new set of wheels for the moon.
Teachers, your students can experience driving the rover themselves. For more information, look for the Lunar Electric Rover in 3D on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to visit our Facebook page and leave a comment. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.